Welcome to the Data Hall YouTube channel. In our previous video, we discussed about how do we construct Fama and French three-factor model. We also discussed about the different ways of constructing a portfolio. So we discussed about the univariate portfolio, the bivariate independent and the bivariate dependent portfolios. Then we also discussed about value weighted and equal weighted portfolios and how to construct the SMB and HML factor. In this video, we are going to discuss how do we construct the Fama and French three factors in Stata. And lastly, I'm going to show you that how much our factors, the factors that we have generated, are correlated with the factors that are available on the Kenneth Fama's website. So we compare our factor with the original factors and see how much correlated our factors are. So this do file is quite self-explanatory. I have given a lot of comments. You just have to change the working directory, and if you are working with CRSP and CompuStat data, then all the variables that we use are exactly the same. The name of the variables are exactly the same as there are in the CRSP and the CompuStat database. So I have given a details of each and everything. So we import. So there are different sections within this do file. First, we do the stock identification. We prepare the stock identification file where we identify different stocks that we have. Then we prepare the delisting information. Then we move on to preparing the monthly stock returns. We adjust our stock return to delisted stocks. We calculate the excess return. Then we clean the CompuStat data. We merge the CRSP and CompuStat data. Then we move on to calculating the market cap for the size sorting. In previous video, we discussed that market cap for the case of size sorting. We would take the June end market capitalization. Similarly, we move to book to market equity ratio, where we first calculate the book equity, then we calculate the market equity, and then we divide the book equity to market equity. Now there is a lot of details regarding this thing. We just cannot simply calculate the book to market ratio. We would have to be specific about the time that we would have to use for book equity and the time period that we use for market equity. Lastly, we move to size and value portfolio sortings. We calculate the portfolio returns, and then we would test the accuracy of the factors that we have constructed with the one that are available on the Kenneth Fama website. Okay. So because this specific do file is constructed on the basis of CRSP and CompuStat data, so I'm using the exact same variable names. For example, in CRSP data, we have Permano that identifies stocks. Then we have exchange code for different exchanges. We have share code where we can identify the common stock and the other stocks, mutual fund, etc. I have given detailed description of each of these variables and how this code would work. I'm not going to discuss all the details in this video. I'm just going to execute this whole code from this. So there's this timer that I have set. I just want to, at the end of this video, I just want to demonstrate that how much time this code takes to execute. So what I'm going to do is I'm going to execute this code. Pause the video, and once you reach at the end of the timer, we can show you how much time this code took to execute it. Now the code had executed, and we can see that it took around 212 seconds. If I divide that by 60, that would give us the number of minutes that it took to execute this code. So it took 3.5 minutes, and do remember that the data I'm using is monthly data from 1962 till the end of 2022. So this is how much time it took. Now you can download this code, and we can share the exact data files that we are using within this this do file. The reason is that there are copyright violations that we would have to go through. So due to copyright issues, we cannot share the CRSP and CompuStat data, but what we have done is we have made some dummy data sets that you can use along with this code and learn this code and apply it on your own data set. And now lastly, what I'm going to do is I'm going to take the FF factors, right? Okay, this is the do file that I'm going to work with. So the SMB and HML factor that I have created are called mySMB and myHML. I'm going to merge this with the data that I have downloaded from the Kenneth Fama's website. Once I have merged these, we have 738 months. I'm just going to drop the unnecessary data and observations. And this is where you can get to see that how much correlated are the variables that we have constructed, the factors that we have constructed are with the factors of the one that we have downloaded from the Fama Kenneth website. So if I do correlate my factor with the SMB factor that we have created and the SMB factor that we have downloaded, we get 99.99 correlation in case of SMB and 0.97 correlation in case of HML, which is pretty high. Let's look at the R square and the coefficients. We get 0.99 coefficient and our R square is also 0.98. So 98% of variations in the factor that we have constructed is explained by the factor that we have downloaded from the Kenneth website. Similarly, for the case of HML, we get 95 R square and the coefficient is 9.99. So the R square is 95%. Now, this is how close our factors are to the one that we have downloaded from the Fama and Kenneth website. Now, I hope this video was useful. You can download the code and the dummy files that you can use with the code from the link given in description. Do subscribe to this channel and do hit the bell icon.